So for those people that like the little numbers, this is 2.4b, more of the chain rule. So the first one we have is f of x is equal to x squared times the square root of 1 minus x squared. And so a lot of the times, very similar to how we rewrote them on our homework, so I would kind of just rewrite this. It's x squared times the quantity 1 minus x squared to the 1/2. A lot of the times for you right now, that's easier to see. And so we've been talking about the chain rule. It was when we're taking the derivative of the outside function, then the derivative of the inside function. All right? But now, what rule do we also have to use when we take a derivative of this one? The product rule, because we got two functions going on that are being multiplied. So here we go. So how do I notate my derivative? F prime. Very good. And so what is the product rule? The derivative of the first. So what is the derivative of the first? 2x. And then times the second. Plus the derivative of the second. So let's take a derivative of the second. So what gets brought down? 1/2. Then I have 1 minus x squared to the negative 1/2. Right? Done? No, I can't forget the chain rule. So what pops out? Negative 2x. And then, so that's the derivative of my second times the first. So what's my first?
X squared.
X squared. And so that's the calculus part. All right, that's the calculus part. Now let's do the algebra part. So let's simplify this up. So I can't really do too much on this first one. I get just 2x and then 1 minus x squared to the 1/2. But I have this 1/2, and I have this negative 2x and then this x squared. So what does that all become? 1/2 times negative 2 is negative 1, right? So I have negative, how many x's? X cubed. And then I still have 1 minus x squared to the negative 1/2. So now we're going to factor out least powers like we did at the end of pre-calc. Man, I wonder if that pre-calc teacher knew about this stuff. All right. Man, he's good. All right. So we're going to factor out least powers. So now I have my 2x and my negative x cubed. What can we factor out of that? Just an x. Just an x. All right. And then I'm looking at this 1 minus x squared to the 1/2 and 1 minus x squared to the negative 1/2. So we factor out the least power. So I factor out 1 minus x squared to the negative 1/2. Now I got to see what we're left with. So I took out an x from a 2x, so I'm left with 2. And then I factored out a negative 1/2 power from a 1/2 power. So that quantity is now to the power of what? 1. That is to a power of 1. And that, honestly, guys, is the whole reason behind why we do it. Right there. Right there. All right? And then what's left? I took out an x from a negative x cubed, so now I have a negative x squared. And then let's simplify this up a little bit. So let's distribute our 2. So it becomes what? 2 minus 2x squared, and then minus x squared. So I still have an x chilling up top from this one right here. And then this part becomes what? 2 minus 3x squared. And then this portion, where does that go? The basement. All right. And so I'm going to put it on the basement. And I'm going to just write it as the square root of 1 minus x squared. Now, could you say it's 1 minus x squared to the power 1/2? Yes, but I want you to see both ways. All right? I want you to see it in both notations just so you're not confused with that. All right? All right. Ansley's going to read down below.
Many times when working with raw derivatives, we can simplify by factoring out the least power.
All right. Again, what was the hard part? Was it the calculus? No, it was the what? It was the algebra part. All right. And so when we're working with these fractional powers, okay, a lot of the times, even if you're not using the fractional power, if you're using a product rule with the chain rule, you're going to be factoring out a least power. All right. It doesn't have to be a fraction. All right. Let's look at this next one. So now I have f of x is equal to x over the cube root of x squared plus 4. Now, what rule does it look like we need to use? It looks like we need to use the quotient rule. Could you use the quotient rule?
Yes.
Yes. I don't want to. It gets ickier than it needs to be, in my opinion. All right. So if we have this fractional square root thing going on in the denominator, things are going to get icky as is. So I'm going to rewrite this. And so I would rewrite this as x times x squared plus 4 to the power of what? Negative 1/3. That's honestly the way I would rewrite it. Can you use the quotient rule? Let me get this straight. Can you use it?
Yes.
Yes. However, it's going to get a little icky. Will you still get to Tampa?
Yeah.
Yes.
If you don't break math rules, you still get there. All right? But this is the way I would suggest going. All right. So here we go. F prime. What rule are we going to use again? The product rule. So the derivative of my first is 1. And then I have x squared plus 4 to the negative 1/3 power. Then plus the derivative of my second. So what gets brought out front? Negative 1/3. And then I have x squared plus 4 to the negative 4/3. Does anything pop out?
Yes.
A 2x pops out. And so that's the derivative of my second. And then times the what? The first. Well, what's my first? X. All right. Pretty good? All right. So now, let's simplify it. All right. So on my right, I can't really do anything to my left, so I just have x squared plus 4x, 4 to the negative 1/3. And then on my right side, this negative 1/3 and this 2x times x is really what? Minus 2/3 x squared. And then I have x squared plus 4 to the negative 4/3. Now, there's a couple things that you probably don't like about this one. Let's talk about those couple things. What are the couple things that you probably don't like? The one? Okay, I don't think that is really too bothersome, but what I have a 1 and I have a negative 2/3. So what's going on here? I got a fraction, right? And so I don't want the fraction to work with it. And so what could I factor out? If I have a 1 and a negative 2/3 x squared, what could I factor out here? I don't want to go full 2/3 because then I still have fraction dealing with. I'm going to factor out a 1/3. I'm going to factor out a 1/3 here. And now if I'm leaving with my x squared plus 4 to the negative 1/3 and x squared plus 4 to the negative 4/3, what could I factor out? It's my least power. X squared plus 4 to the negative 4/3. Now, what am I left with? I factored out a 1/3 from a 1. So I am left with what?
3.
3. All right? Because it's really 1 divided by 1/3, which is 3. And then I'm left with x squared plus 4 to the power of what here? If I factored out a negative 4/3 from a negative 1/3, that's left with a power of 1. All right, and that's the whole reason behind why we do it. And then if I factored out a 1/3 from a negative 2/3, I'm left with negative 2. And then I still have this x squared chilling. All right, pretty good there?
Yes.
All right. And now we're going to distribute. So I'm going to distribute my 3. And so what am I left with? 3x squared and then plus 12 minus 2x squared. So in my numerator, what's left? 3x squared and negative 2x squared become what? X squared. And then plus 12. Then in my denominator, I still got this stuff going on. So I now have a 3 on the bottom, and then I have x squared plus 4 to the power of 4/3. And so there is my derivative. All right? Pretty good? All right. On this one, I have y equals the whole quantity of this 3x minus 1 over x squared plus 3 all raised to the power of 2. And so now my inner composite's a quotient. You see this? All right, so that's kind of like my u. But my outer composite's a squared function. All right. So when I take a derivative, what needs to be brought out front? A 2. And so the 2 comes out first. And then I'm still left with this 3x minus 1 over x squared plus 3 to the power of what now? 1. And then I'm done, right? No, I need to take the derivative of the what? The inside, the inner composite. So what rule do I have to use on this one? I have to use the quotient rule, so let's do it. So, what's the derivative of the top? 3 times x squared plus 3, and then what? Minus, very good. And then 2x, the derivative of the bottom, times the top of 3x minus 1. All over the bottom squared. This x squared plus 3 quantity squared. So now let's distribute to simplify. So we have 3x squared and then plus 9, and then we're distributing our negative 2x to give me what? Minus 6x squared, and then plus 2x. All right. So dy dx would equal 2. And then I also still have this 3x minus 1 going. All right, so from this part right here. And then I also have what? What would this combine to in our numerator? 3x squared and negative 6x squared becomes what? Negative 3x squared. And then plus 2x, and then plus 9. All over. Now, I have an x squared plus 3, and I have an x squared plus 3 squared. So what's in the denominator here?
X squared plus 3 cubed.
Very good. And then I am done. All right. All right, so here we go. So we know all the derivatives of these 6 trig functions. We know them. All right, the derivative of sine is cosine, right? However, we can't forget all the chain rule. So now we might have a composite inside of a trig function that something's going to pop out. All right. So if we look at this, we have y equals sine of 2x. Well, how would I notate my derivative, first of all? dy dx is equal to, what's the derivative of what's the derivative of sine? Cosine. But I still have cosine of 2x. So now my inner composite is this 2x. So I need to take the derivative of 2x. So what's the derivative of 2x? 2. So a 2 pops out. All right. And yes, I put the 2 in front. I left some space. All right. Most of the time, you guys right now will probably put it behind and then move it forward when you simplify. All right, let's look at this next one. I got y equals cosine of x minus 1. So dy dx, what's the derivative of cosine? Negative sine of what here? X minus 1. And I'm done. What pops out? 1. So what am I? I'm done. All right. So did the chain rule really apply on that one? Kinda, but not really. It didn't change anything because my derivative was 1. All right. All right, let's look at this next one. I got y equals tangent of 3x. So my derivative, dy dx, what is the derivative of tangent? Secant squared. Of 3x. And I'm done. No. What pops out? 3. The derivative of 3x is 3. All right, pretty good? All right, I want to do one more. So I'm going to say f of x is equal to secant of 4x. F of x equals secant of 4x. So how would I notate that derivative? F prime. Very good. Well, what's the derivative of secant? Secant tangent. All right, secant tangent. So I now would have secant of 4x tangent of 4x. And then what pops out by the chain rule? A 4. All right. Now, I want to share a common mistake that I see every year. I've been doing this a little while. When I tell students to take a derivative of something like secant of 4x, a lot of the times they'll give me the answer of 4 secant x tangent x. Okay? Don't get rid of this inner composite. All right? If the function is secant of 4x, we need 4x on those. Does that make sense? Yes, the 4 does pop out. True that. All right? But you can't get rid of this 4. Does everybody hear me? All right. Just like we did sine of 2x, we still had cosine of 2x, right? Now, we did have a 2 pop out, but we still had 2 cosine of 2x. All right, cool. All right, I want to talk about parentheses, and you can take notes however you wish. All right, so I want to talk about the importance of where parentheses are located. So if I have cosine of 3x squared, that is cosine of the quantity of 3x squared. You follow me? And so if I take a derivative of cosine, what is the derivative of cosine? Negative sine, right? So I'd have negative sine of 3x squared. But then what pops out? By the chain rule, what would pop out? A 6x, and then you simplify it. All right? If I have cosine of 3, then x squared, cosine of 3 is just a number, guys. All right? Just like pi or e. They are not pi or e. It's between negative 1 and 1, right? But it's a number. You following me? So it's a constant multiple. So my function here is just x squared. So when I take a derivative of this one, what would be brought down? A 2. So the derivative there would be a 2 x, and then I'd still have cosine 3 chilling. All right, because cosine 3 is just a constant multiple number. Okay?
Wait, cosine's a constant multiple number?
This next one, I would have cosine of the quantity 3x squared, which is really cosine of 9x squared. All right, because we'd square the 3x there. Well, what's the derivative of cosine? Negative sine. And so I'd have negative sine of that. But then what would pop out by the chain rule? An 18x. All right. All right, and then this is the most common mistake that I see with you guys right now. A cosine squared x is really the quantity of cosine x squared. All right. And so what needs to happen here is what needs to be brought out front? A 2. And so I have a 2 and then a cosine x. And then what is my inner composite here? Okay, the derivative of cosine, which would be negative sine. And then we'd simplify it up. All right? And sometimes we need to rewrite it. If it's a square root, we need to rewrite it as a 1/2. So this is when a 1/2 comes out front, and then power of what? Negative 1/2, and then what pops out? Negative sine. All right, and then we could simplify it. All right, pretty good? All right, but sometimes we have a chain rule that's more than one chain. We might have 2 chain. All right?
And if you knew you have the king.
True that. All right, so let's look at this one. I got f of t, which is equal to sine cubed of 4t. So, here we go. So I would kind of rewrite this for you right now. I would say this is like sine of 4t quantity cubed. All right, if it's sine cubed of that, that's kind of how it's written. So if I'm taking a derivative, I'd notate it by f prime of t. So what would be brought down first? A 3. So now I'd have a 3, and then sine of 4t to the power of what? 2. But now, what am I taking the derivative of? Okay, my inside, which is this sine of 4t. So I need to take the derivative of sine. So what is the derivative of sine? Just cosine. So now I have cosine of what? 4t. Now I need to take the derivative of what? 4t. because 2 chain. So the derivative of 4t is 4. And now we simplify it up. So f prime would equal 12, and then sine squared of 4t, and then cosine of 4t. All right. There you go. There you go.